Hello, and welcome to this module on SQL injection. Let's see what we'll be covering in this video. We'll start off with some basic database concepts. Then we'll move on to the different types of SQL injection. We'll follow that with SQL Injection Objectives. What are we trying to achieve with SQL injection? And then move on to testing for SQL injection. And then finally, we will end off with countermeasures against SQL injection. Let's get started. So if you want to be proficient at SQL injection, you actually have to know how a database is structured and how a database works. So having a programming background will become very, very useful in this module and in your career as a penetration tester. But let's just walk through some basic database concepts that we'll be covering in the demo later so that you understand exactly how a database is made up. At the highest level, we have the database server. Now, the database server can have multiple databases on it, and each database is independent. You could have them joined, but generally they're independent. So at the next level, you have a database. And after that, in each database, you have tables. And tables are made up of columns. And then in the columns, you have the rows, which is the actual data. So that is, in essence, the database hierarchy. So you have the database server. On the database server, you have a database. In the database, you have tables. In the tables, you have columns. And in the columns, you have rows, which is all your fields, your data fields. So let's move on and let's see if we build this out. So a database can have multiple tables, and it can have multiple rows and multiple columns. So you must think of this as a tree, a hierarchical tree. It's very important for you to understand this concept. So for example, in this diagram here, this database has two tables. This table only has one column, but this table has two columns, etc., etc., and multiple rows. Then let's just say, for argument's sake, there's another database. That database might only have one table, one column, and one row. But it is still a database because it still contains data. But this is the structure that you must always keep in mind when doing SQL injection. Let's move on. Let's look at the types of SQL injection. At the simplest level, we have simple SQL injection. That's generally when you put in an unvalidated SQL script and you get something back. And we'll see a demo of that later. We also have what's called blind SQL injection. Now, what blind SQL injection, it's similar to simple SQL injection. The only difference is you're not getting data back into the browser, but you are still injecting data or scripts into the database. We also have union SQL injection, where we join two different sets of data together and see what error messages or what data disclosure we can get out. And then finally, we have error-based SQL injection, which is generally used for disclosure. In other words, if we just keep throwing errors into a SQL database and getting error messages back, eventually the database starts to build itself out. And that talks to the previous slide, where we were trying to figure out what the database name is, what tables it has, what columns it has, etc., etc. And those are the four primary forms of SQL injection. Let's look at some SQL injection objectives. Okay, so why do we actually do SQL injection? Not just for fun, we obviously want to gain something out of it. And there are a few things that you get out of SQL injection, which is why it's probably number one on the OWASP top 10 as the exploiter vulnerability to be careful for, because it has very, very powerful effects. Let's look at them. So, first of all, you can get remote code execution. In other words, you can inject scripts or code into a database and have them run on the server. We can make availability an issue. In other words, we can take the server offline. We can drop the database. If your database is open to SQL injection and you have the correct permissions, you can run a drop command and have the whole database disappear. That will affect availability. We can bypass authentication. Most web applications use some form of authentication, username and password, and SQL injection, in historical and probably the most basic facts, is we use bypass authentication. So we bypass the actual need for a password by using SQL injection and get access to the system without needing a password. There's also information disclosure. You can start building out the database, look at the database names, and at worst case, you can actually exfiltrate the whole database and post it online, like some people have done recently. You can tamper with data integrity. In other words, you can change data in the database, change the values of fields and rows and columns, which will affect the actual integrity of the data and the integrity of the system. You could also grab passwords. You could dump the entire password table and then reverse engineer the hashes into clear text. And then finally, as we discussed in the information disclosure, you can exfiltrate the entire database. And this has happened more often than not. Let's move on and look at how we test for SQL injection. So how do we test for SQL injection? Well, there's just a few things that we generally look for, so let's take a look at them. First thing, does the database exist? That's the first thing. If you've got a web application, assume that some web applications don't have databases. They might be static, pure HTML. So we need to first confirm that the database exists. We then follow that with listing the database fields, and by that I mean we enumerate the database name, the database tables, and the columns in each table. We then test for injection. In other words, can we change the integrity of the data? Can we put commands or scripts into the database that will then run in the browser, or in some cases run as a blind SQL injection? We always test for input validation, and that's a software development best practice. So in other words, can we write scripts into the database, or will the database only accept the characters that it's built for? In other words, if it only accepts images, will it test for images, or will it also accept text? If it only accepts text, can you put scripts in, etc., etc.? And then we'll look at joining unions as well. In other words, putting unions between tables and trying to get the database to act erratically so we can get some more information out or look at some form of vulnerability. And then finally, error messages, which are a godsend to penetration testing, because error messages often have a lot of information in that help us enumerate the database. You know, it gives us the table names, gives us the database name, gives us which users are logged in, etc., etc. Let's move on and look at the countermeasures. So what are the countermeasures against SQL injection? Well, the primary one is always minimize your admin privileges. So when you're setting up a database, you generally have a user that interacts with that database on behalf of the web application. That user should have minimum privileges. It shouldn't be a full sysadmin on the database. It should only have access to the database that it is interacting with. Suppress errors so that we don't disclose information. So set your debug mode to off, so that when the system or the database or the application throws an error, it doesn't actually disclose any real information other than oops, something went wrong or something similar to that. Input validation we've discussed, but I mean, as a software developer, you must make sure that anything that's coming untrusted from the user, anything untrusted from the actual web application, must be validated to make sure it is the data that you're expecting. Tested in dev. This goes without saying, but often a lot of people just move stuff straight into production without actually running a test in development. And part of the test you should be in development, other than user acceptance testing, regression testing, load testing, is penetration testing to make sure that your application is secure. SQL vulnerability scanning. Just like with web applications, you should also run vulnerability scans against your database or against your web application before the attackers do, because guess what? They will be doing it when you move it into production. And then finally, constant vigilance. As with web applications, web servers, and any other system that's out on the internet and open to attack, always make sure that you keep an eye on your database. Monitor for changes, monitor the logs, view any error messages that are being generated from the web application, etc., etc., so that you can proactively stop an injection attack before it gets any worse. And that pretty much ends this video on SQL injection. Thank you for watching.